A square bar of sides 400 mm and 300 mm long is subjected to an axial compressive load of 400 kN. Determine the Young's modulus and Poisson's ratio. If the decrease in length is 0.75 mm and increase in sides is 0.03 mm. Here they are given square bar. The side of the square bar is 40 mm and it having a length of 300 mm. So that according to this problem, the given data given B is equal to, the side is considered as B, breadth is equal to 40 mm. Next, 300 mm long, this is considered as L. L is equal to, length of the square bar is equal to 300 mm, that is represented by L. Is subjected to an axial compressive load. The load is represented by P. P is equal to 400 kilonewton. 400 kilonewton. So next, determine the Young's modulus. Young's modulus is represented by E. E is equal to what? Next, and the Poisson's ratio. So we need to determine Young's modulus as well as Poisson's ratio. Poisson's ratio is equal to what? Poisson's ratio is equal to what? Next, if the decrease in length means change in length, decrease in length is considered as delta L. Delta L is equal to 0.75 mm. Delta L. And also decrease in sides. So side is considered as D or B. So delta of B, this is the decrease in or change in side is considered as delta of B. Delta of B is equal to 0.03 mm. Okay. So here first we need to consider standard, or we need to convert into standard units. So here the breadth is given in the form of mm. L is also given in terms of mm. Both are in mm. So no need to convert here. So here P is equal to 400 kilonewton. So kilonewton we need to convert into in terms of Newton. So that P is equal to 400 into kilo is converting into Newton, means 10 to the power of 3. Kilo is written as 10 to the power of 3 Newton. Now, E is we need to find out, Poisson's ratio is also need to find out, and delta L, it is also in terms of mm, delta B is also in terms of mm. So now we need to, first we need to find out the value of stress. So Young's modulus, according to Young's modulus definition, E is equal to stress divided by strain. Okay. So here E is an if you want to find out the value of E, we should know the value of sigma and epsilon. So E means before finding of E and here we don't know the value of sigma and epsilon, so that first we need to find out sigma. Sigma is equal to F divided by A, or we call it as P divided by A, load divided by area. So P divided by A, sigma is equal to load. Here we know the value of load 400 kilonewton, means 10 to the power of 3, divided by area. Here the area of the square bar. In a, we know to find out the value of area of the square bar. So length into length or breadth into breadth, or we generally call it as side into side. The area of the square bar is determined by using side into side. Here the value of side is 40. So that 40 into 40. Sigma is equal to, now we need to solve these things. 0, 0, 0, 0 cancelled. Remaining term 4 into 10 to the power of 3 divided by 4. So we will get around 250 of Newton per mm square. The value of sigma will become 250 Newton per mm square. So here we find out the value of sigma. Now we need to find out the value of epsilon. Here two things are given. One is length and another one is side. So here we are considering strain of longitudinal strain and lateral strain. In a longitudinal strain we are considering length. So longitudinal strain. Longitudinal strain. Longitudinal strain is equal to, epsilon is equal to change in length to the original length. So here we know the value of delta L. Delta L is 0.75 mm. So it is in terms of mm, 0.75 divided by L. L is an original length. Original length is 300 mm. So epsilon means longitudinal strain, or we can call it as EL, epsilon of L length. Epsilon of L 0.75 divided by 300, we will get 0.0025. This is the longitudinal strain. Similarly, now we can find out the value of E. E is equal to stress divided by strain. Substitute the value of stress and strain in this equation. So value of stress is 250 divided by strain is 0.0025. The value of E, it will becomes, value of E is 1 into 10 to the power of 5. 1 into 10 to the power of 5 Newton per mm square. This is the Young's modulus. Next, longitudinal strain. Now we need to find out the Poisson's ratio. So Poisson ratio is equal to, Poisson's ratio is equal to lateral strain divided by longitudinal strain. Here we already find out the longitudinal strain, but now we need to find out the value of lateral strain. So that the lateral strain is equal to, change in width. So change in width delta of B divided by original width is B. Now substitute the value of delta B and B. The value of delta B is 0.03 divided by original width is 40. So that the lateral strain is equal to 0.00075. So this is an lateral strain. Now substitute the value of longitudinal strain and lateral strain in an equation of Poisson's ratio. So Poisson's ratio PR, Poisson's ratio is equal to lateral strain. The value of lateral strain is 0.00075 divided by longitudinal strain is 0.0025. The Poisson's ratio, the value of Poisson's ratio becomes 0.3. Poisson's ratio is equal to 0.3.